Hello and welcome to video number 7, where in this video we're going to talk about storage devices. So firstly, what is the point in storage devices? There's lots of different storage devices out there, but we're talking about secondary storage. So we know main memory is volatile, and that's no good for us here. We need a place to permanently store our data so that when the power's off, we can retrieve all that data again. We're going to talk about all the different types of secondary storage, but there's two main types of secondary storage that we really need to get to grips with. And those two types are HDD or hard disk drive or SSD solid state drive. Now HDD is very common, but SSD is on the rise. Tablet computers, smartphones and modern laptops tend to use solid state drives. Now, what's the reason for this? Well, mainly, solid state drives are much quicker, they're a little bit more expensive, but that cost is being reduced. But we'll go through that in due course. So by now, if you've followed through all of these videos, we should really know what is stored in primary storage. But we need to know what is stored in secondary storage. So basically, we've got the operating system and its utilities, the user applications, and user documents and files are all stored safely in secondary storage. Past exam questions lead us to believe that you're going to be asked to compare the speed, the cost, and the portability of each of these storage devices. So let's go through the first one then. We've got hard disk drives. Hard disk drives come under the subtitle of magnetic storage, as does floppy disks and magnetic tapes. But because those two are so outdated, I'm not actually going to talk about those today. Hard disks are very common. We've been using them actually commercially since 1957. It's a very high capacity storage medium, meaning we can store lots of gigabytes or even terabytes on some hard drives. And to be fair to hard drives, it's got a fairly fast access time and it's got a fairly fast transfer rate. The speed is pretty quick, the cost is quite cheap, and the portability is quite small, but it has moving parts which could cause a problem. Now, hard disk drives are not as fast as SSD, which we'll see later. Now I'm going to take you through how a hard disk actually stores data. So each disk is a platter, and each platter is coated in iron oxide, which makes each platter magnetic. It's important it's magnetic because that's how we actually write our binary data to it. So there's a special read-write head which will move across the disk and change the polarity of the magnetic surface to either a 1 or a 0. The read-write head, as it moves across the disk, can also read the data as well. Now the arm is controlled by an actuator, which is a magnet that moves very, very, very quickly. But this doesn't allow the arm to reach every part of the disk. In order to do this, the disk has to spin. Then once the arm can reach any part of the disk, the data is encoded in binary, which is a 0 or a 1. So if you look at this diagram, and this is the diagram that the exam board will be using, we've got different parts of the platter that we need to be aware of. So what you're looking at there is an actual disk from a hard drive, but in a diagrammatic form. The parts of the disk, such as a cluster, is multiple parts of the disk itself. We've got a track, which if you think of it as a running track, will run all the way round. And you've got a sector, which is different parts of the disk going from the inside to the outside. As discussed before, the disk can actually spin around, and we measure that in revolutions per minute. So if you think the faster the platter can spin, the faster the data can be read or written to the disk itself. The first hard drives themselves will spin at around about 1,200 revolutions per minute, but now we're looking at about 7,200 revolutions per minute, so we've really moved on in the technology. Speaking of moving on, let's look at solid state drives. Now these are becoming more popular, and there is no moving parts here as opposed to the hard disk drives of the past. Spot the deliberate mistake. They use a special type of ROM, not RAM, called EEPROM, which stands for Electronically Erasable Programmable Read-Only Memory. This is perfect, as we know ROM is non-volatile. And SSD tends to give us a better performance than HDD, which means it's a lot quicker, and it tends to be more expensive and have a lower capacity because the technology is fairly new. There's no physical motion, which increases speed because the read-write head doesn't actually have to move up and down a disk here. This is all electronic. What about these devices here? Memory sticks and memory cards. Now, be careful, students. Some students describing memory sticks have used the term USB, and there you will get no marks. USB stands for Universal Serial Bus, and that is something completely different than a memory stick. So be careful. So, memory sticks and memory cards, such as SD or Secure Digital is what it stands for, they use solid-state technologies. So, all of the advantages and disadvantages that we've discussed for solid-state drives applies here as well. So we might as well apply our exam tip here. Speed, it is much faster than HDD, but that means the cost is higher for now as technology improves. Also, portability, they are still small, which makes it quite good for portability, and there's no moving parts, so if it gets damaged, if you drop it, there's absolutely no problems there. So next, we move on to optical storage. And when we say optical storage, we're talking mainly about compact discs. These work using lasers, and no, it's not as exciting as it sounds. They burn microscopic indentations into the disc. They start from the middle and work their way out. Indentations and their absence creates pits and lands. And basically, lands are 1 and pits are 0. So you can see how we represent our binary. If you need to read from the disk, the laser shines its light at the surface, and the surface light, it gets reflected back, and it's measuring how much light is actually reflected back, in which we can work out our zeros or our ones. As you can see from this image here, a DVD has a much higher quality because it can fit more pits and more lands into the disc itself. DVD will use 2 layers, and it will use 2 lasers to measure the different wavelengths. Applying our speed, CDs are actually slower than HDD, which makes them also slower than SSD. The cost, well, they're fairly cheap, as the CD has a small capacity. They're very portable, as they're not easily damaged unless you decide to go mental and take a screwdriver to the surface of the CD. So I think it's important now that we actually look at a very, very popular exam question. This one's from 2017, and it says, explain how fragmentation can occur on a secondary storage device and describe what occurs during defragmentation. So what I'm going to do is highlight the key parts of this exam question. Now, it talks about this word fragmentation, and also it talks about defragmentation. And it also explains secondary storage devices. Now for me, I know that fragmentation only occurs on hard disk drives. SSD uses something called the trim command. And what trim does is it allows an operating system to inform a solid state drive which blocks of data are no longer required or are in use. So then we can wipe data internally. And the reason we use trim is because we just don't have the physical moving parts, and we're not able to instruct the read-write head to move to the different parts of our disk and put the data in order. Remember, SSD is all electronic. Well, what actually is fragmentation? Well, let's look at our disk again. Over time, the file system that your operating system communicates with fills up. Obviously, as you add more data in and you increase the number of files you've got, you will always be changing and deleting things, and that will change the addresses in your file table. So as you can see in the diagram, I have added lots of different dots there. Those dots represent bits of your files. And you'll notice on the disk, all of those dots have become scattered or fragmented across the disk. And this means that our read-write head has to physically go to these locations, and it slows down the system and increases the time taken to access files. So then looking at defragmentation, all it does is it consolidates the data on the disk into one place. It moves the parts of the files back together. So as you can see, all I've done is I've changed my data to red dots now so you can clearly see it. I've moved all of the data into the same track. And as the disk spins, the read-write head doesn't have to go all over the disk to find the data anymore. It's all in one place, which means we have a faster access. And the final tip for today is to be prepared for a scenario. The exam board may want you to make recommendations on a secondary storage device on a given situation. And that's it for video 7. Hopefully you've enjoyed this one again, and maybe I will see you next time.